Hello, ladies and gentlemen. Today we are going to take a look at some basic postulates and theorems to start the year and how we can connect this to your algebra connections from the past, essentially. How we can use algebra to help us find missing lengths of segments or angles. So let's first start with those two key words, postulates, theorems. So what do those two words really mean? Well, in geometry, we're going to be given a lot of facts about diagrams or about properties of certain shapes. And within those facts, you'll see them labeled as either a postulate or a theorem. It's important to know that they're pretty much the same thing in order to use them, like a truth, right? But a postulate versus a theorem, there's a subtle comparison there. A postulate is a statement that is assumed to be true without any sort of proof. So you just assume that it's true and you go from there. Whereas a theorem is sort of like a theory. It has to be proven to be true, and it can be proven to be true. So you're going to see them labeled as both true facts, but one of them is something that can be proven, whereas another one cannot be proven. It's just assumed to be true. So let's start with a couple postulates to get going. Actually, 4 postulates here we're going to do. And remember, these are facts that are true, but we assume that they're true and don't really need any further proof, okay? So segment and angle postulates coming at you. The first postulate we need to write down is what's called the Ruler Postulate, and it's pretty basic. It says that the points on a line can be given coordinates, and we can use the coordinates to find the length. So in other words, we can plot points on a number line similar to what you did in prior math classes, and you can find the distance in between them by simply subtracting those numbers. So if I said that I have a segment here and this one is 5 and over here is 7, and I wanted to find the distance from A to B, well, you'd go, well, that's just 7 minus 5, 2. The distance would be 2. The ruler postulate is something that says that we can legally do that the distance will be in between those two coordinates. The segment addition postulate says that segments can be added together to create larger segments. So it's legal to add segments together, not just numbers, okay? So segments can be added together to create larger segments. If I was going to use this diagram, notice that AB, the length from A to B is labeled here, B to C goes from B to C here, and A to C is the whole part here. So this postulate really says you can take a piece plus a piece and it will equal the whole. Or in other words, using the letters on our diagram, the distance from A to B plus the distance from B to C will be equal to the distance from A to C. That's what the segment addition postulate says, that segments can be added together to create larger segments. And again, remember, these are postulates. Nobody had to write like a formal argument as to why they were true. It's just sort of we assume that that's okay and we'll go with that, okay? Now, continuing on, segments and angles, they kind of behave the same way. Segments we measure with a ruler, angles we measure with a protractor. So when we talk about protractor postulate, we're saying that the measure of an angle is the absolute value of the distance of the real numbers associated with the sides. So it's the same sort of argument that you can use a protractor to measure angles. If we were to measure this angle shown by side C there and D labeled in this picture, the red bar and the line, or the red ray and the blue ray here, we could find this number 45, and we would find this number, oh, that's kind of a yucky one, like 148, and we could subtract those two to find the measurement of that angle. Okay, the protractor postulate says it's fine to use those numbers on the sides as well, just like you do with a ruler, to help you find the distance in between the two rays. The angle addition postulate is just like the segment addition postulate. It says that it's okay for angles to be added together to create larger angles. It follows the same sort of rule, that one piece of an angle plus another piece of an angle would equal the whole larger angle. So in our diagram, this is what it looks like. If S is in the interior of angle PQR, then the measure of angle PQS is this one right here, this red one, P to Q to S, that'd be this one, plus the measure of angle SQR, this one, would equal the measure of the whole thing, PQR, this whole angle here. And that's helpful because if I knew that this was 100 and this one was 40, I could then add them together to find the total angle measurement to be 140. So I can use these facts about rulers, protractors, angle addition, segment addition to find missing lengths or degrees in diagrams. So here's another place where this algebra comes in. I need you to write this one in your notes. We don't have a picture, so we're going to create a picture here. We have example 1. We're going to use some angle vocabulary as well as some postulates here given. So given that ray BX bisects angle ABC, and the measure of angle ABX is 5x, and the measure of angle XBC is 3x plus 10, it says find the value of x and the measure of angle ABC. So there's a lot of things going on in here. There's letters that we need to try to figure out what kind of angles we're talking about. There's the word bisect in there. That's a key idea. And we have some algebraic stuff like the 5x and the 3x plus 10 that we're dealing with. So it's time to put this all together. Let's first draw a really good picture, and then we'll see where that leads us. Given that ray BX bisects angle ABC, I'm going to stop right there. See, what's happening is I have an angle ABC. I'm going to draw it. I'm going to put A over here, B right here, and C here. It doesn't matter if you make it obtuse, acute, right, doesn't matter. We know that ray BX bisects it. So we know that BX, I'm going to place X on there. This is an angle bisector. Bisect means to cut in half into two equal parts, two congruent halves, if you will. So I'm going to place a little slash mark here on this angle and a matching slash mark on this one. Because they're both one slash, or I could make them both two slash like this, they match up. They're congruent. Their degrees or their measures would be equal. If I look at the rest of the problem here, or what I'm given, it says the measure of angle ABX, that's this top skinny one here, is 5x. And the measure of angle XBC, X to B to C, that's the bottom piece here, 3x plus 10. It says use that to find the value of x and the measure of angle ABC. Well, first we have to find x. Now remember, those two algebraic expressions we wrote in here were on congruent angles. This one is congruent to this one. And congruent means their measurements are equal. So what this is telling me is that that label 5x, that number of degrees, is actually equal to the number of degrees labeled with the 3x plus 10. So if I use my algebra skills now to solve this equation, I would want to get x on one side, subtraction here, 5x minus 3x is 2x, 2x equals 10, dividing by 2, x equals 5. So I know that x is 5, that's one thing I was supposed to find the value of x. Now find the measure of angle ABC. So if x is 5, I can take that and plug it back in. This angle right here is 5 times 5, 5x, right? 5 times 5, 25 degrees. And this one would also be 25 degrees because it was bisected after all. So the measure of angle ABC then would be a total of 50 degrees. Notice how we used our vocabulary about the word bisect and being able to draw. And also we used some algebra skills to solve for x. And we did angle addition here to add those two pieces together to solve for angle ABC. Let's take a look at a segment one. Given that B is between A and C on a segment, so I'm going to do that first. A and C are on a segment and B is between them. It doesn't say it has to be in the middle now. It doesn't say bisect. It does say AB is 3x plus 1, so I'm going to label that. And then it says B to C is 2x minus 2. And then it says A to C all the way across is 64. So using what I know about segments and how segments work, I can add these two little segments together and it would equal this big larger measurement of 64. So if I add 3x plus 1 plus 2x minus 2, it would equal 64. So if I combine length terms on this side, I'd have 5x, a positive 1 and a negative 2 makes a negative 1. 5x minus 1 equals 64. Add the 1. 5x equals 65, divide by 5, x is 13. So I know what the x is. I can find the value of x, 13. And then how would I find AB and BC? AB, BC. So to find from A to B, of course, do the same thing. Plug it in. 3 times 13, 39, plus one more, 40. And then B to C would be whatever's left out of 64, or you could take that 13 and plug it in. 2 times 13, 26, minus 2 more, 24. Check. Do they both add up to make 64? Of course. Okay. So that's how we use our algebra and our postulates here to find missing measurements on geometric